that, let's talk about the first concept, which is route distinguishers and why behind it. Okay, so here you go. The topology is actually very simple here. If you see, right, then we have one router which is R2, right? And this router is having two virtual routers or the VRFs. We have VRF A here and we have VRF C here. You must be wondering where exactly the VRF B. Actually, I changed the topology a little bit because you understand the VRFB was there with the orange color when we were talking about the route linking. So I kept it there and I moved to something else, which is very important to actually link the routes, right? So what I'm doing here is we have two VRFs configured on R2. Number one is VRFA, which is the green VRF. If I say green VRF, you should understand it's a VRFA. And another VRF is the VRF gray, which is VRFC. And these guys are learning routes over OSPF via router X. Where this X is? I haven't showcased this router X in topology, but it is somewhere here, right? This is your R, this is your router number X. So basically, between this VRF and this X, a routing protocol is running, which is OSPF. And that is why from X you are learning, this green VRF is learning two routes, 10.10.10.0, this one, OSPF learn route via X. And you are also learning 10.10.30.0/24 via X. It is as simple as that, right? Interesting. So there is another router which is virtual router C or VRF or the gray router, and it is also connected with some router Y, and it is running OSPF between this VRF and this router Y, and Y is advertising some of the routes, some of the OSPF routes towards gray router. As you can see here, the 10.10.10.0/24 via Y and 10.10.50.0/24 via Y. And if I give them the number, this is route number 1, this is route number 2, which are part of VRF green, and this is route number 3 and router number 4, which are part of VRF gray. And you can see route number 1 is exactly equal to route number 3 because both are 10.10.10.0/24, but they can persist in router R2 because they are part of two different routing tables. One routing table belongs to green VRF and the other routing table belongs to gray VRF. It is as simple as that. They can coexist with each other, right? Right? But if it was the case, right, if you're learning these two routes from two different routers, then OSPF is going to select the one on the basis of the cost. And if not, then basically it is going to select both of them to send the traffic. But yes, if it needs to send this route to any other router, then it is not going to send the two routes. It is always going to send only one route, right? And here is my problem. The problem is this router R2 is here, right? And similarly, we have router R3, and we all know that we have Prashant Patilji, which has created this service provider network. Now, R2 and router R3 are exactly facing customers, and that is why we have two different VRFs configured on router R2, and we have two different routers configured on R3. The one is green one, the other one is gray one. And these are the routers R2 and R3 which are facing your customers, right? And that is why Mr. Prashant Patil with this network engineer saying that I do not need to run the IBGP protocol in my core. What are the cores? Whatever routers Mr. Prashant Patil has in his service provider network, which are not customer facing router or the edge routers, they all come into the category of core routers. And Mr. Prashant Patil does not want any headache to be involved, and that is why he is not running anywhere IGP between its core. Nowhere the IBGP is running. Interesting. He is just running OSPF protocol as it is. Okay, that is great. Then, so what is the need here? The need here is how R2 is going to advertise all these route over this IBGP peering towards R3, right? You know the solution. We have been discussing about it because the problem is not with respect to 10.10.30.0 route in VRF, this one, not with respect to 10.10.50.0 route in VRF gray. The problem is with respect to these two route number one and route number three, which are exactly looking same, right? So basically what is going to happen? What we are doing here is between R2 and R3, we are also running IBGP, right? And as soon as I run IBGP, of course, we are going to advertise the route. And before that, you all should understand that right now the routes are into the OSPF, right? Guys, just wait a minute once more. Okay, so can anybody please confirm? Am I audible now?
Yes,
Okay,
sure.
sure. So, so what is happening here, guys? The problem is not with respect to route number one. Uh, sorry, route number two and four, because these are totally different routes. The problem is with respect to 10.10.10.0, which is route number one, and route number three in other VRF. So what is going to happen? Let's talk about it. Now we are running BGP, and right now these routes are into OSPF. If I want to send them into the BGP, the first thing first we need to do is we need to advertise these routes into BGP, right, from OSPF, from their respected VRFs into the BGP, right? But let's not talk about it because the focus of this board is not the redistribution or advertisement. The focus of this board is to understand a concept and the why behind it, right? But you all know that if you want to send this route into the BGP, of course, these routes should be first thing first, should there be in the BGP. And we are running the IBGP. If we have this route in the BGP, then what BGP is going to do if you do not do anything? Then of course you are getting the four routes in BGP 10.10.10.0/24, right? The other route is going to be 10.10.10. Not 10. This is 30.0/24. The other route is going to be 10.10.10.0/24. And then the last route is going to be 10.10.50.0/24. These routes are from VRF gray. These routes are from the VRF green, right? Sorry, yeah, green. It is as simple as that, right? And here is my problem. When BGP sees that these are the two same routes, BGP is going to say, I will select a best route out of these two, route number one and route number three, and I'm going to send only one. And this is what BGP does, right? Through the BGP path selection algorithm. It is as simple as that. And if it does that, then from here you want to send the four routes, but BGP is doing the best path selection and it is going to send the three routes. Which three routes? Of course, out of these two, it is going to send only one. Which one? We do not know, right? On the basis of best path selection. Maybe it can select the best path from the gray VRF, or it can select the best path from the green VRF. It is as simple as that, right? So only one route should go out of this, and then basically you are going to send this route, which is route number two, and then you are going to send this route, which is route number four. So at R3, you are going to receive only route number one, route number two, route number four, if you do not do anything, right? And this is my problem. It means that if you have selected the route, maybe the green route, it is going, and the second problem is actually how it will go. How will R3 BGP process comes to know, right? Where do I send these route? Interesting, right? So this is my problem. I was interested in sending 4 routes, but BGP process is sending 3 routes, which is not correct because these 4 routes is different to me, right? Although the BGP system is thinking that the route number 1 and route number 3 are same, but those are not, because any customer can come with the overlapping address range. What is the meaning of overlapping IP address range? There could be another customer can join, which is maybe using the same network again, 10.10.10.0. It means that for this customer also, I will not be advertising the route because BGP can only advertise one best path after the best path selection algorithm if it is learning the same path from multiple sources. It is as simple as that, right? So you can understand there is a problem, right? Right now there is a problem. It means that what I need to do, I need to differentiate these routes. I need to make sure that the BGP understand this fact that the first route, right, the first green route is from customer A, and the third route is exactly this one, right, is from customer C or the VRFC. It is as simple as that. And how I would do that? How will I make this difference? How will I make sure that BGP understand it? It is done on the basis of a number, right? So I believe you understand that why do we need this number now? We need this number, otherwise BGP get confused. BGP says that these two routes are same, but these two routes are not same. We want to create a difference between them. We want to make sure that the BGP understand the difference, and that is why we are going to attach a number at the front of this route, right? So you understand the why. Now we are talking about the solution. The solution, this number is known as actually route distinguishers because it is used to distinguish or differentiate routes from different customers. It is as simple as that, right? So let's move to the next board because in this board we just discussed why behind route distinguisher, and in the next board we are going to see what are and how we can uh, attach these route distinguishers value, right? Having said that, let's move to the next board where I have included this number. So by the way, guys, this number which I was talking about in the previous board exactly looks like our community. Its its values actually are divided. It is divided into two parts. This number, which number we are calling this number as the route distinguisher. This number is actually divided into two parts. The first part is of 16-bit. The second part is again of 16-bit. Here, generally, in the starting 16-bit, we write the autonomous system, and the ending 16 bits, we write any number, right? These are a great amount of number, 2 to the power 16. You can understand that, right? Interesting. So, the RD looks like exactly same as community, right? So what is going on here? Again, I would like to tell you that green router, we are running the OSPF process. In the VRF-A, which is the green VRF, we are running the OSPF process. In VRF-C, why we are running? Because it is getting the route into the OSPF, from the OSPF, right? From this guy is getting the route from X, this guy is getting the route from Y. It is as simple as that. Now we have green routes, now we have gray routes, and now see what we are doing. I am making a document which says the route distinguisher value for VRF-A is 200 colon 1111. This number is any arbitrary number, and this number is your autonomous system. It means that the BGP which I am going to run here, through which I am sharing the route, is running AS number 200. It is as simple as that, right? And the RD value for VRFC, which is this route, which is this virtual router, which is the gray virtual router, right? It is going to be 200 colon 3333. You can have this value anything, but yes, you should have this value. This is absolutely important when you specify the VRF. you should specify this route distinguisher value, because on the basis of this value, BGP differentiate routes, right? Otherwise, there is no difference in route number 1 and route number 3, right? So what you are doing is you are attaching this number whenever you advertise this route from router 2. BGP differentiate these routes, the green routes and the gray routes, on the basis of this number. And this number is known as the RD value, right? Route distinguisher value. So at the front of all the routes from green VRF, we have put 200 colon 1111, right? Route number 1 is having 200 colon 1111. Route number 2 is also having 200 colon 1111. Why? Because we have defined in this VRF that the RD value is 200 colon 1111. And how to define that? You just need to go IP VRFA. This is how you create the VRF, right? And then you do simply RD is 200 colon 1111. So BGP exactly sees that what exactly the value of RD you have configured. Whatever the value of RD you have configured here, it is going to take those route and advertise them into the IBGP. But along with that, it will attach this RD value, right? So this was your NLRI, or the prefix, which is we are calling IPv4, right? And this is the RD value. But now you can see your prefix looks like this: RD value plus IPv4 subnet, right? And this is not the normal looking route, right? Previously, we were just sending only IPv4 part, and that is why it was creating problem, right? Now we have attached the RD value. The problem is solved. Why? Now BGP sees that this route, the route number 3, right? Route number 3 is totally different than as compared to route number 1. Why? Because they are part of different RD values, right? Route number 1 is part of 200 colon 1111, and route number 3 is part of 200 colon 3333. We are not differentiating route on the basis of only IPv4. We are now differentiating on the basis of RD value too. And if a protocol is capable of doing that exactly, that is not the normal protocol, because now it is not taking IPv4 route, guys. It is taking RD plus IPv4 routes. And we call this RD plus IPv4 routes as VPN v4 routes. Why VPN v4? Why we have given this name? Just try to understand. This name has two parts, VPN and v4. v4 means it is going to be the IPv4 route. At the end of the day, it is IPv4 route. You all understand this, right? But why VPN? Because we have different VRFs, right? We have VRFA, we have VRFC exactly here, right? Some routes are from VRFA, which is the green router, and some routes are of VRF gray, which is of your VRFC. It is as simple as that. It means that we are having routes from different VRFs. What we want to create, we want to create a virtual private network of this green VRF, and we want to create another virtual private network for this gray VRF. It is as simple as that, and that is why. And of course, the first one which I draw here, this one, the complete, the VP, it is known as the, we want to create a complete private network for VRF A, or the customer A, and then we want to create a complete a virtual private network for VRF B, right? Or sorry, VRF C, and that is why we call them the VPN. Private virtual private network here doesn't mean that your traffic is encrypted. This does mean that over the shared service provider network, these two different customers with having the same IP address range can communicate, right? And that is why we call them the VRF v4 or the VPN v4 routes. It is as simple as that, right? So the protocol which is taking these VP and V4 routes are IBGP, but this is not the normal IBGP, and that is why we call them the multi-protocol BGP. Why? Because previously we all know that it is capable of doing IPv4 routes. It is capable of sending and receiving IPv4 routes. We all know about it. Why? We have spent 15 hours in BGP learning, right? And we have seen that it is capable of doing IPv4 routing. And now I am saying it can send VPN v4 routes. What are the VPN v4 routes now? These routes are actually your RD value plus IPv4. If you are sending RD along with the IPv4 value, then these routes are VPN v4. Believe me, guys, this routing protocol can take the multicast routes also. This routing protocol can take the IPv6 routes also, and so on. And that is why we are calling this protocol as multi-protocol BGP. There is no difference, but yes, there are some difference in the configuration. We need to tell R2 that you have the powers of sending or receiving VPN v4 route. We need to inform R3 that if R2 is making a peering with you, actually that peering is not the normal peering, it is the multi-protocol BGP peering. It means that you can receive IPv4 routes, you can receive VPN v4 routes, but we need to configure that what we are sending. It is as simple as that. But one thing is pretty clear from the fact here that if we want to send these routes, it should not go as an IPv4 route. We need to attach the RD value along with it so that BGP process can differentiate these routes and BGP can send all the routes here. It is as simple as that, right? So my problem at R2 is resolved because the BGP process at R2 was previously selecting the best path out of this path number 1 and 3, right? And it was only sending one path. But if I attach this RD value, BGP process in this router R2 is going to see these two routes as a different routes, and it is going to send all of them. Interesting, right? So we understood why do we need a route distinguishers and where exactly we are going to attach them. It is as simple as that. If you guys any doubt about the route distinguisher concept, please do ask. Otherwise, we are going to move to route targets, which is another interesting thing. You can simply raise your hand if you do not have any doubt. Okay, Mr. Burak has a doubt. Mr. Burak, please ask your question.
Okay, Vishnu, thank you. I understand the main purpose of route distinguisher, but I wonder that where route redistribution comes into play
Route,
in this scenario.
route redistribution you are talking about.
Yeah. Uh-huh.
Okay, so uh, just see this picture, right? Okay, I will showcase you. This is a very interesting question, and thank you so much, Mr. Burak, that you have asked. So what we had here, we had this router R2, right? And this R2 is going to have this VRF, and it is going to have this VRF. This was the VRF A, this was the VRF B, right? Now we are getting a route into in this VRF A, right? Say this is 10.10.10.0/24. This is the OSPF learned route, right? And here we have another route. Okay, leave about this first thing first. The VRF portion leave. Suppose we have a normal router, right? And on the normal router, basically I am receiving one route from here, which is the OSPF learned route, and say this is 10.10.10.0/24, right? And on the other hand of this router, I am running the BGP protocol, right? This is my R2, this is my say R1 from where I'm getting the OSPF route, and here is my R3, right? Now the question is how this R3 is going to get this route from the OSPF. R2 is going to have this route into the OSPF table, right? It is going to say 10.10.10.0/24, 0/24 is learned via R1. Now suppose if I want to send this route towards R3, there are two approaches. One approach is I have this route in the routing table, right? So what I'll do is I can use the network command. I mentioned that I forgot to tell you that we can do this via another thing also. What? We can now R2 is running two processes, here OSPF, here BGP. And what if I want this OSPF route into BGP? I can redistribute this route into BGP by going into the BGP configuration mode, router, BGP, right? Maybe 200, and then I will write redistribute OSPF routes. As soon as I do that, this route from the OSPF will come into the BGP routing table as a route. That 10.10.10. is run via 0.0.0.0 means this is the router which is redistributing this route, and now R3 is going to get this route, right? It is as simple as that. This is the normal thing. But yes, you can argue with me that we could have done this using the network command. Yes, but you know that if we do not have network command, then we can redistribute it also, right? But how this is the only thing in the VRF scenario, let's understand that. Suppose we are having we are having this VRF A here, which is receiving this route 10.10.10.0, and we are having this VRF B here on the same router, which is having this route maybe 10.10.20.0/24. It is as simple as that, right? And now I am running the BGP process here. Okay, and by default, the BGP process is actually what it is doing. We run only one BGP process, BGP router 200. It is not like that I am running a OSPF process here for VRFA that I mentioned in the last class, and we are running also an OSPF process here for the VRFB. As many as VRF you have, you are going to run all. You are going to run OSPF in every VRF, but BGP is evolved as a protocol, and it doesn't need to run with respect to all the VRFs, right? Sorry, separate process for all the VRF. It doesn't work like this. So what we do is we have the address family for VRFA, and we have the address family for VRFB, right? Interesting. And now if I see, if I do a show IP, if I run this, if I do a show IP BGP, I am not going to see this route at all, right? Which route? This route or this route? And what I'm doing here, I want to advertise all these route in the BGP, right? If I want to do that, that first thing first, BGP process 200 should know that what are the routes in the VRFs, right? And whatever the address family I'm writing here, this is for the BGP. This is not for the OSPF. Routes are in OSPF. So first thing first, what we need to do is we need to send this routes from VRF-A into BGP and VRF-B also into BGP so that this BGP can advertise them. But yes, in this case, now BGP attach whatever whatever the route I am getting, I will be attaching the RD value, whatever you have configured here, maybe 1:100, right? From here also, when you redistribute, basically it is going to attach the RD value, right? But now you can ask me that why cannot we do this with the network command? Network command actually going to check your routing table, right? The global routing table, that whether you have this route or not. And if you don't have this route, you don't have this route in the global routing table, right? And if you do not have this route, then how BGP is going to learn that? And that is why we are doing redistribution from these VRFs into the BGP. BGP can do that redistribution, right? Because here in the specific address family of VRF-A, you are going to say redistribute BGP, sorry, redistribute OSPF. Then what is going to happen? Router is going to see that, okay, there is a VRF-A and there is OSPF running. Whatever the routes are there in the OSPF, I will be having that in this address family, VRF-A. And guys, I have to talk about this, right? This is a separate concept, but as you asked that why do we need it, I'm just explaining. Burak, did it make some sense to you?
Yeah, a little bit.
Yeah.
And
But the
still,
whole soul, yeah,
sorry.
but the whole soul concept of this address families, I will be explaining it, because if I explain you, if I talk about it, then I have divided MPLS into three parts, right? One thing
Mhm.
is basically VRF, which we are talking about. Yes, there are some part which needs to be understand from the address family, which is your multi-protocol BGP. Do not worry about it. We will be talking that why we have these address family concept, right? But for now, understand only this much. That is okay. That why do we need redistribution? Because the routes are in OSPF and we want them in BGP. Then, and if the network command is not working, then we need to redistribute it. And because BGP supports that. Okay.
Okay, I understand that I need to hold my horses.
Right, you are. Okay. So
Okay.
now, Mr. Prashantji, your question, please.
Vishnuji, I have a question regarding this redistribution only.
Mhm.
I tried in GNS3, I was getting interviewer of redistribution is not allowed from the BGP when you are doing redistribution in OSPF. Same way, if you are in BGP, you're trying to do a redistribution from OSPF, there I got a different error.
No doubt about it that you are going to get it, and that is why we are reading route distinguishers and route target. Once we are done with
Okay,
that, I will be back to your problem. Don't worry. And that
okay.
is what I wanted,
Yeah,
that you should go through that building of those three routers. And you should understand that it is not straightforward. It is not like that, that you will be able to redistribute them. And why? We are just knowing the why behind it. If you do that lab and come here in this class, then basically it is going to increase your knowledge like anything. Okay, Mr. Prashant?
okay. Yes. Ashnazi, I have one more question.
Mhm.
Okay. So here you said that we have a BGP, multi-protocol BGP. Is there any other protocol which can carry different VRF routes from one source to destination apart from MPBGP?
I don't see that any other protocol like OSPF. I think. Hmm. OSPF doesn't take that, but you
Okay.
can. But there are some recent development. There are some development in the OSPF too, which can take some of the extra information. But yes, these RD plus IPv4, I do not see that. I think I need to check whether this thing is taken by OSPF version 3 or not. But I'm not sure about it. Definitely RIP cannot take it. EIGRP is not developed to do that. OSPF, there are some developments in last 5 to 10 years through which it can take some of the information, because in segment routing I have seen that OSPF can take other information too along with the route. But again, the maybe portion is there, so I would rather choose not to answer this question for now, right? Maybe I do not know now, but probably we can talk about it in the next class. We can discuss it. You can do your research on this, and but for me right now, it is the multi-protocol BGP which is these capabilities of sending the multicast IPv6. But yes, this is the protocol which can take all these things, right? IPv4, VPN, v4, multicast, EVPN, right? Or the basically the layer 2 MAC address is also can be taken by the multi-protocol BGP. Not as exhaustive as this protocol, other protocols are, but maybe some protocols can take few things, but not all of them, whatever the multi-protocol BGP is supporting. Okay.
Okay. Vishnuji, same. I have one question regarding this VRF configuration only.
Mhm.
See, this RD and RD value. See, here we have router using the same address. I always get confused what I need to configure for this RD value.
Here, the RD value should be different for this VRF and for this VRF, right? That is what I said.
Uh-huh.
If the route is same, you do not need to worry about it. And that is why we have chosen this extra number, so that router does not get confused, right? You are right that this route 10.10.10.0 in VRF green is absolutely same as 10.10.10.0 in VRF gray, and that is why we are attaching a number here, right? Route distinguisher is not configured on the basis of per route. It is configured on the basis of all the routes in your VRF. If you have 100 routes in this VRF, the route distinguisher is going to be same, one number, right? Because now you can differentiate this routing table with this routing table, right, Mr. Prashant?
Okay, Vishnuji. Yeah.
Yeah. Now let's move to, thank you so much for your good questions. And now let's move to why behind another number. Why do we have the similar looking number one more time, right? So let's first understand the why behind it, right? And this is where I could see the most of the problem with 95% of the guys who understand MPLS. I'm not saying who do not understand MPLS. I'm saying this is the problem with 95% of the guys, that they say that we can actually do not we can work with only RD. I don't see that why do we need RT, right? Guys, believe me, the developers of the BGP or developers who are doing this effort, right? These developers are exactly so frugal about the code that they do not want to write anything extra. If something is required, absolutely required, or it is making the process more efficient, then they are writing the code for it. So if somebody has written the code for RT, it is required or it is making the process much more efficient, right? So it is not like the fact that we can work without RT. No, there are many scenarios, many scenarios where RT is absolutely necessary, and that is why they have made it necessary, right? But let's first thing first, let's try to understand why behind it, right? Because this is our mantra of learning anything. Same topology, everything is same. We are having here one set of route in the green VRF, and we are having another set of route in the gray VRF right here. We are pretty comfortable with this RD value. And when BGP advertise this into IBGP, right, that is where we are attaching these RD values. So we have RD plus R, we have RD value plus we have RIPv4 route. We are not mentioning anything with respect to RT. I want to just prove that because only with these two numbers, there are some problems which you are going to face. And whatever the problem of Mr. Prashant Patil in their service provider network, we are here to solve it, right? Because he is building that network step by step. So we have explained him the concept of route distinguisher. He's pretty happy about it, but let's see what is the problem he's going to get. Now, R2, so where we were solving problem from the RD here, right? Because previously BGP was advertising only one route. When we put RD value, it is going to advertise this route, route number 1, route number 3 as well, along with the 2 and 4. There was no problem with respect to route number 2 and 4. But there was problem with respect to route number 1 and route number 3. Previously, when we didn't have the RD, only one route was going towards R3. But now, because we have these RD value, all the routes are different. And all the routes are going towards R3. And here is my doubt. Once it is reaches to the BGP process of the R3, how will BGP decide that which route is for what? Interesting. And then you all will say in one single voice that Mr. Vishnu, the green route should go into the green VRF and the gray route should go into the gray VRF. And that is why we have this RD4, right? So the BGP process will say whatever you have in 200 colon 1111, which is the RD value, you should send it from here to here. And then whatever you have in the RD value 200 colon 3333, right? You need to send it to the gray one. It is as simple as what is the problem here? There shouldn't be any problem, right? Interesting, right? We can do without any other number. RD can handle this. There is no doubt about it that RD can handle it. But still, we haven't sent route at the destination on the basis of RD. And you know why? Right? So now here basically what is going on? My problem was that how to send from this BGP process this route back to this green VRF and to this gray VRF. We are saying we can do this on the basis of RD, because if it is 200 colon 11111, right? Send it in the green. If it's 200 colon 3333, send it over gray. This is the problem. The problem was that, and the solution was here, right? So we are here also using RD to send the value into the respective VRF, but is it the correct approach, right? If I do that, then what should be the problem? And that problem I'm going to explain you into the next board, which exactly going to talk about that we cannot do that simply on the basis of RD. And why? Let's see here. Again, the topology is same. This guy is a green VRF and this guy is the gray VRF, and I have changed this route. The route number one is little bit changed from 10.10.10.0 to 10.10.20.0, and here is my problem. The problem is Mr. Prashant Patil is adding some restrictions now. He's saying that the VRF-A route should go into the VRF-A of router R3, but I have a special VRF which is VRF-C, and I want that the first route of this VRF should only go into the VRF green at the destination. This is very, very interesting, guys. Mr. Prashant Patil is now putting some restriction that you cannot advertise whatever you want on the basis of RD, and I'm putting some restriction here. He's saying that VRFC's first route should go into the green VRF here, although it is a part of VRFC, but at the destination I want that this route should go into the green VRF. Can I do that? Actually, you will see these kind of requirements comes in the MPLS network, right? Because there are some customers basically which are the shared customers. We call them the shared services also. Maybe this is built by the service provider, Mr. Prashant Patil, and he has several routes. Means he have 100 of routes for the customer A. He has 100 of route for the customer only C, so that only customer C can come here. Or maybe he can have 100 of the routes for the customer C, D, E, right? You cannot create that on the basis of only ID, and why? I will let you know, right? So Mr. Prashant Patil is exactly putting some restrictions on advertisement of the route. He's saying that VRFC route number one should go on only into the green VRF, and route number two should go only to the gray VRF. Now let's talk about the gray VRF, right? If we are doing only on the basis of RD that what route should go into which VRF, what we are going to see, right? Here, I will be seeing that the green VRF RD value is 200 colon 1111. Then I will be importing all the routes from green VRF, right? Right? So what routes are those going to be? 10.10.10.0/24. It will be in the green VRF because I am taking these values from the basis on the basis of RD. I am importing or I am sending the route from the BGP towards this VRF on the basis of this RD. So 10.10.30.0 should also be here, right? But if I do only on the basis of RD, what will go into the routing table of VRF gray? It will have the both the routes 10.10.20.0/24 and 10.10.50.0/24. Is that what you needed? No, Mr. Prashant Patil has put some more restriction. Mr. Prashant Patil does not want this route, this one, to be into the green table, sorry, to be into the gray table. He wants this route to be here, but on the only on the basis of RD, which you have to define per VRF, right? You have defined this VRF value here, RD value 200 colon 1111, and here you have defined the RD value 200 colon 3333. And if you want to do the routes advertisement to this VRF on the basis of only this RD value, it is not going to meet Mr. Prashant Patil's conditions. And if that is the case, then you need something more than this, right? You need something more than route distinguishers. And that is where another number comes into picture, right? And what is that other number? So basically what I'm doing is I am along with this route, this is my RD value, this is my IPv4 route. Along with that, I am just giving some more information that boss, Mr. BGP process at the destination, this route is for green VRF and this route is for gray VRF. And when this router R3 sees this little piece of information, it will send the 10.10.20 here, and it will send the bottom route, which is only for the gray VRF, right here, 10.10.50.0, which is right here previously also, right? So what this green little information which we are tagging along with the RD and IPv4 is actually your route target. And this is again the number which looks like community. The starting 16 bits are going to be the AS number. The ending bit 8 bits can be, sorry, 16 bit can be any number, whatever in which you are interested in, right? So this is for absolutely sure we cannot meet the conditions of Mr. Prashant Patil, route advertisement conditions only through RD value. We need another number, right? So if we are needing another number, so the developer says that we will take decisions at the destination that which route should go where on the basis of RT value, this little bit piece of information. And when we advertise route, if we want to distinguish these routes, we are going to distinguish on the basis of RD. Why? Because RD alone was not capable of meeting all the requirement of Prashant Patil G at the destination, right? And that is why if we are choosing something that how we are going to send this route to respective VRF, we are choosing that thing on the basis of RT. But if you want to distinguish route, we are doing that on the basis of RD. It is as simple as that. Okay, guys. But now let's see these things in action, right? I will put some RT value in the next board according to Mr. Prashant Patil condition. But now Prashant Patil is getting more greedy in terms of its condition. He is putting some more restriction. And why I'm putting some more restriction? Because I want to showcase you the power of RT. If we had done this only with RT, we wouldn't have seen this much functionality. I would like to showcase you on the next board, right? And here you go. We have the next board here, which is actually going to explain you the concept of route target, right? But in the last board, there is a definitely from last two board, we understood that there is a definitely need of a new number on the basis of which we can send the route at the destination, right? So again, the topology is same. We are having this green route. We are having this uh, gray routes. We are attaching the RD value so that this router does send everybody of all of them. Otherwise, if we do not put the RD value, BGP is going to understand some of the routes are same, right? So we are attaching this RD value from here. This is my green VRF routes and this is my gray VRF route. But now Mr. Prashant Patil has changed some of the requirements. And what are the requirements? He is saying that the first route, by the way, this is your route number 1, this is route number 2, this is route number 3, and this is route number 4. Mr. Prashant Patil is putting most of his requirement on the VRFC here. And he's saying the route number 3 should go in green VRF as well as gray VRF, right? And he's saying 10.10.50.0 should go only into the gray VRF at the destination. And this is my destination, which is R3. It is as simple as that, right? So there is no doubt about it that I will be able to advertise this route, all the routes from the BGP, right? And BGP, when advertise them, it is going to put this RD value, right? Why RD value it is going to put? Because it wants to differentiate these routes, and that is why it is sending them. And this is your multi-protocol BGP over which it is sending. But now the question is how we are going to make sure that what route should go where, right? So I will inform this R3 that, right, that import in this green VRF. Import means get all the routes, right, which are having 200 colon 123. Now I am assigning a number here. Interesting. And this number is actually RT value, which is looking just like the same. The starting is AS and the ending number could be anything. So what I'm doing is I am giving the same RT value to both the routes of VRF A, which is 200 colon 123. And that is what I'm saying, Mr. Green VRF, you need to import everything which is having this RT. Now I'm taking the decision on the basis of RT. So green VRF will going to get this route number 1, route number 2 without any doubt. This is my route number 3 and route number 4, and here is all the magic happens, right? What Mr. Prashant is saying that the 10.10.50.0 route should be available to the green VRF, and that is why in the gray VRF, and that is why I am writing import, right? Import 200 colon, because we want only the gray only the 10.50.0 route. It should be here only, right? So I will be writing here import 200 colon 888, right? As soon as I do that, uh, then which route is going to install here? Whatever the route is there, right, with this RT value 200 colon 888, which is, and by the way guys, I can attach more than one RT value. So whatever the routes are there with 200 colon 888, I will be importing it, and that is what Mr. Prashant Patil wants. The 10.10.50.0, which is having 200 colon 888, should be imported here, and this route 10.10.10, sorry, 50.0 is going to be imported into gray VRF. It is as simple as that, right? But as soon as I write 200 colon 888, it will be checking that what other routes are having, right? What other routes are having this 200 colon 888. So it will receive this 10.10.20.0 also, because here in the RT value it is written 200 colon 888. It doesn't need to match everything. If this guy is having this RT value, it is going to be imported here, and that is what you want. See, 10.10.20.0 and 50.0 should part of your gray VRF, which is right here. And basically on the basis of this import decision, import commands, or basically import statement, you are making this decision, right? You are importing all the route which are having 200 colon 888 into this gray VRF. But here is all the magic happens. Now green VRF also wants 10.10.20.0, and along with this import statement you will be writing one more statement, that you receive 200 colon 123, you also receive 200 colon 999. What is going to happen? Out of all the routes whatever we are carrying in the R3, we will be checking that where exactly 200 and colon 999 is prepended, right, or attached. And there is only one route that is satisfying this condition, which is 10.10.20.0. And that is why I will be receiving this 10.10.20.0 slash 24 in the green VRF on the basis of this RT value, right? So this route 10.10.20.0 will be installed in the green VRF because we are importing it on the basis of RT. And this is, you need to be in your mind always, this information, that at the destination, the decision is going to take on the basis of RT value, what route should go where, right? It is not on the basis of route distinguishers. Why? Because route distinguishers actually were not able to meet Mr. Prashant Patil's or all the requirement which we are going to see in the service provider network. And that is why the BGP developer was thinking aloud, and they were saying that if I cannot do with RD, I would need a new number, and that number is RT. And now they are saying, let's remove the confusion altogether. We are not going to use RD value in any circumstance for at the destination for sending these routes. We are exactly going to say that on the basis of RT value, we will be selecting the route, which route should go into the which VRF. So RT is for selecting the route at the destination, which route where should go where. RD is actually to distinguish these route. Otherwise, the BGP protocol is going to select one route out of the similar looking route. It is as simple as that. Interesting, guys, right? And believe me, it is not difficult at all. If you have slightest of doubt, that do not worry about it. Just watch this recording at the pace of maybe 1.5, and you will be amazed to see that everything with respect to RD and RT is so clear, right?